Welcome back to Meteorology 101. It's been a little while since I did a video, so we're going to jump into this thing. I'm going to pull a surface chart. We do a little bit of surface analysis. We have some severe weather out there right now in, I think, south central Texas, and then in the panhandle of Texas. So we're going to keep an eye on that stuff. We'll maybe jump over there and see what's going on. But I want to do the surface analysis first and find out what features are affecting that and why, and maybe we can pull out some details. So right now we got isobars. We got lines of equal pressure, high pressure off the east coast. So just looking at the pressure lines alone, I would say out of this low pressure system to the north, probably got a cold front wrapping around that high, and then maybe becoming stationary through here, or even a warm front because we got that southerly flow pushing that warm moist air out of the Gulf. So maybe with the low over southern New Mexico, maybe we got a warm front right there, cold front coming out of that. Now these lines start getting straight over the coast, over the water, just because there's a lot of not a lot of data there, so the computer just kind of analyzes those as a straight shot. So we got, that's just the basis of it. If we look at basically just the lines of equal pressure, we show the isotherms on here. We get some, we start pinpointing some thermal advection. So if we have any thermal advection, it's pretty weak right through here. We do have quite a bit right through there over Texas, so we got plenty of warm air advection over eastern Texas going up into Oklahoma, just to the southern part of Oklahoma. Really nothing in Arkansas. We got a cold core system at about 16 degrees, that's about 61 degrees Fahrenheit, right over southern Colorado, northern New Mexico, and then it looks like a 20-degree cold core system. Just a cold core, cold pocket sitting there at the surface, right over Iowa. So kind of see what's going on there. I would suspect this cold core system, if these are moving, maybe, not even like, not quite a cold front there, but, a little bit of a boundary as those cold pockets move, to the east or southeast, then you can get a little bit of lift, low ceilings, moisture being pushed up and just causing some low level clouds. So we'll get an idea of what's going on there. We pull the surface plots. So it even looks like, even right over here is a 28. That's like a warm pocket right there over Nevada, southern Nevada. And then, like I said, these are kind of extrapolated once they get off the coast. So we could probably close a lot of these off, but that's a warm core, cold core, cold core. I don't see anything else closed off. Maybe up to the north, but that'd be all cold. So, like I said, with the frontal system, let's keep an eye on that too, where that frontal boundary is going to be. See what this computer generates. Right now, let's throw the surface plots. Get an idea of what's real, what's not. Like this low pressure system. Get my tool here. That low pressure system over south New Mexico. There's your rotation right there. You can see the rotation right there. I would push that low probably a little bit more to the north. And then the center of that low. So now you got this, look, see that cold core system. So that's a cold core low. Over the mountain range, pretty much over the Rockies, so a little bit colder in the upper levels. Like I said, 61 degrees, so it's not freezing. Then we got that 20 to the north up there, and that one is that's about 68 degrees Fahrenheit. It's a little bit hard to see on these with all this data on here, but there's that. It's about 68 up there. So if we look at our surface plots, we can see there's a 62, but these surface plots are a little bit newer than what those isotherms are. So we got to kind of keep an eye on that too. Right there's a 70, so we're getting close to that 68. There's a 67, so right around that, and then you're getting down into 62 right in the center of that thing. So you do get a cold core system with a 62 pushing about 17 degrees. We said that one was 20, so about 17 being the cold core. Alright, so let's go with the fronts real quick. Actually, look right around here where that low pressure system is. There's a lot going on down here with this ridging. So we got basically low, troughing, ridge. You can see our rotation right there going that way. That's a ridge. We see rotation kind of going like that, so that's a trough. It'd help if I use the right symbols. There's a ridge, there's a trough. Now troughing right there, you can see that rotation. Like I said, you got here's your wind directions right here, big old S curve. So we got here's thunderstorms being reported right there over the panhandle. We got winds going out of the northeast, then winds out of the south. So we got basically divergence at the surface right there. So that'd be like basically an indication of downward vertical motion to have that divergence. We got winds going out of the south. Well, we want to see here's rotation right there. I'm making a mess. So winds out of the south and then shifting from the northeast. So there's your wind shear right there. So right over the panhandle, right over northern Texas, I'd probably look for some severe weather possible right there, just because of just the indication of rotation on the surface. Looks like a little bit of divergence there. We got actually here, clear that out. Here's a rotation right there over southern Texas too. So keep an eye on that. And then we got these ceilings, this red with rain. We got ceilings. This is a ceiling of 800 feet, so that's below 1,000 feet. That's why that station is red. This is showing mist, so visibility is between 3 and 5 miles, or the ceilings between 1,000 and 3,000 feet. So that's all the blue. So a little bit lower ceilings there, very low ceilings there. And then down here we got this thunderstorm actually being reported central Texas, and a ceiling of 900 feet. So it's below 1,000. We're showing IFR conditions, and then we got 20 knot winds onshore flow, and then a 5 knot wind coming out of the northeast. So with this onshore flow, and then we got those blue stations where, like I said, the ceilings, these are showing broken right there. These two, so that's ceilings 1 to 3,000 feet, and then this one's going IFR with a ceiling of 900. So we're getting a little severe with those winds pushing in onshore, and possibly have maybe a little low-level jet there. We'll see what happens where the jet stream is. If we go that high on the charts, probably not going to have time to do that right now, but onshore flow 20 knots, that's a pretty good indication that you're pretty good instability right there, especially with that rotation. So keep an eye on that. Let's throw the fronts on here real quick. Alright, so this is showing that low, which we said was up here. They're showing warm air advection, almost like a high pressure system blocking that warm air advection, but I'm not buying that too much. Let's see here. We do got the warm air advection here though. We know that. So that could be an indicator of a warm boundary. This is putting another low pressure system up here to the north, eastern Kansas, and then low, actually warm air advection out of that with a warm front. So if you had rotation around the low, then you really want to have some sort of a cold front there. And then if you had that low down here, then a warm front. So you almost have to go kind of stationary, but I'm not buying into that 100%. We got southerly winds. Okay, I could probably go with a little bit of warm air advection there. Let's look at our temperatures. 67, 72, 74, 78. That's even warmer. 64. So 64, 62. Yeah, we probably got a little bit of warm air advection right there. So I would say place the front right there. That's fine. Push it to the north. we got a lot of cloudiness over Ohio right now. So we do have an indication of a warm front because we have stratiform clouds out there. If you look at the, I'll pull up my camera here. So that's a lot of stratiform clouds right there. So we're looking at a stable environment. So I could agree with the warm front pushing to the north, just to the south of southern Ohio. So I can agree with that one. Now the low pressure system, let's see if we got a low pressure system. We'll go erase this. Throw up the data alone. And let's see where we have a low, if we had that low. Got southerly flow. So moving out in my drawing. Got southerly flow. Going southeasterly. And southerly, it's all southerly. I don't see any easterly winds. South to southeast, warm air advection out of the south, but I don't really see any rotation indicate another low. You got a little bit there, maybe a little troughing. Rotation down here, definitely rotation there. Right there, out of the south, out of the south. This is all out of the south, so our winds are just straight up out of the south. We're not having any of that rotation to prove anything, except for low ceilings. If you place this low right there, and then we could go north of that northerly flow into the lower ceilings and bring that warm front all the way around. So something like that. We have the warm air advection. Now the cold air advection we would have to almost take out of that low, basically bring that cold front back, but you want to see some sort of wind shift, temperature changes. And there's a 65, then a 48, and that's done at 93. That's a warm. So 65 and 93, so we're putting pretty good right there. Let's go see. I just went over that one. 89, 93, 65. So I would put that cold front right through there. So I could agree with that cold front, like I said, with the warm front. And then that's going to be pushing all the way up. We had that high off the east coast, and then all that warm air advection out of the south. Alright, so I'm good with that. Rain, thunderstorms, mist. Looking at the weather station plots. And this data is a little bit older too. So there's rain, and then if we go to look at our ceilings, we're pretty much cloudy all through here, all through that central part. So let's look for rain showers through here. Look for, with this rotation, definitely some rain showers through here, maybe some severe stuff over that panhandle where we were looking at these wind shifts. And then with the thunderstorms over central Texas and the onshore flow at 20 knots, let's look at some severe weather in southern Texas. Alright, so let's get the radar up. Give you a better shot here. We got a tornado warning. Let's see what we have. Let me get you back to... you don't have to read it. Tornado warning remains in effect until 7:15 p.m. Central Daylight Time. And that is another 15 minutes or so. 10 minutes. And then it's Fayette County. And a confirmed tornado was located near LaGrange and is nearly stationary. The hazard is a damaging tornado. The source is weather spotters. Confirmed tornado. Okay, so this one is confirmed. Let's go see what we got for that cell. Let's go back a couple. I read a tornado warning. Then one with the purple was confirmed. The red is a warning. Several tornado warnings in this area, but these cells look pretty weak, really. So let's get into the upper levels. There's a pretty good reflectivity right there. This is a base reflectivity, so We need to go up into the upper levels, which that thing just disappears right away as we go into the higher angles of the radar. So we are in a radar, it looks like, to the west of this thing. Let's see, way to the west. Let's go to the one to the north, see if we can get that data real quick, and then see what we're looking at here. See if we can download that. We got one to the west, just to the west of those cells. And it wants to update, stay in. Next update's about 25 seconds. Sometimes when it gets that close to the next update, it won't populate this screen right away. No data available. Let's see what's happening here. We still got 6 seconds. We have a few other radars around this area, so one of these should give us a loop. Let's go to the east. Radar to the east. San Antonio. I don't know why I'm having trouble with my download today. Probably a lot of people down there downloading data. That's what it is. Once you get these tornadoes, you got a lot of data. People going after that site, so it bogs it down pretty good. So, all right, we got our confirmed tornado. We could do a cross section. Let's go cross over that and see what's happening. All right, we got pretty good angle at the storm. We got pushing high DBZs all the way up to about 32,000 feet. Good angle on that thing. So let's go a little bit further to the south. Still a little blobby there. Let's go with it to this one. We got 60 plus DBZs, and that was pushing about 17,000 feet, and then we get to 50 DBZ on this, we're going up to about 30,000. So, all right, let's go after this tornado. Let's go back a couple slides. Maybe we can. There was a pretty good about 62 DBZs on the surface. Let's go with let's do a cross section on that real quick. See if we can find that area. I can see some purple in there. Let me get up here. Alright, and then that's about as high as it's getting right there. So almost 20,000 feet with 61 DBZs. That's pretty good. Then push it over 30,000 feet with 50 DBZ. So we're cranking pretty good on that. The higher reflectivity is most likely hail. So if we look at this, we're inside that warning area. We've got 1.21 inches of hail. If we do a 3D pattern on this, do a volume scan, now we can actually go pull this up and break it down. So we're not showing much on the surface there. So everything below right around 15,000 feet, or look, maybe 14,000 feet and down, we're pretty much dead on the data. So the radar didn't get, maybe it's too close to the radar, it can't scan that low. So we do got our tilt. We got significant upper level, pushing to the upper levels and updraft, and then well over 30,000 feet, we're pushing almost to 40,000 feet on that at the higher reflectivities. So we got a good tilt on this storm. Definitely, it was a confirmed tornado. So let's go with the latest slide. Let's go to, I'm gonna try to find another radar or something that's I mean, that radar's not super close, so it should give us a pretty good angle on that. This one's even closer, but we weren't getting anything from it, I don't think. We go back to the north, pull that this is San Antonio where we're at now. This one is KHGX Houston. What we got here, and then Central Texas. Alright, we'll give this thing time to load. I'm not looking to do a volume scan yet. Let me get my map together here. Okay. Alright, here we go. Now we can definitely see a little bit of a hook echo there. Got that little S-curve going on. We definitely got that rotation. Let's look at the base velocity. And you can see the strong rotation right there in this area. They just popped up another tornado warning right there. And that is a tornado warning activated. Radar indicated rotation on that red one that just showed up. And then this one is the damaging tornado that's present. Now, let's get over here. Do a cross section right across that hook echo. We got a real good tilt of this storm, so let's go with a rotation. We can actually pull up rotation. Let me get to the volume scan. Go right around that hook echo. There we go. There's our tilt right there. So you see that. I guess when lighter, the weaker DBZ is just kind of highlighted, kind of cloudy around this thing, just to show you the build of the storm. It goes up, you know, all the way up to about 50,000 feet. So that updraft's pushing all the way up there, overshooting tops. And then I can pull out structure solid to show you those overshooting tops. But I always break this down to the center of the core so we can see, you know, there's our tail. We can see our tail on the ground. And then see the tilt of the storm and the higher DBZ reflectivities being pushed to the upper levels. When you're pushing up to 30,000 feet like that, you got a pretty strong updraft. So let's go with the rotation, and this should show us rotation all throughout that storm, and the different colors should be different directions, so you can actually see rotation all the way in the upper levels, and then a lot more horizontal rotation through the center of this storm. So we definitely got the rotation, everything we need for that updraft, and then the heavy rains create the downdraft, and then you get the vortex created. So that's we definitely got the rotation in that storm to be, you know, see a tornado on the ground. Plus, like I say, you see that hook echo. And let's go up to another layer. You can see the overhang on this storm. If we go to the upper elevations of the radar, you can see this area is closed off. There's nothing right there. It's all blank. So we get that little hook echo going on, and then as we go up to the upper levels, this starts to fill. So now the reflectivities are in the upper levels. You can see, say, okay, there's nothing on the surface, but in the upper levels you got the overhang. So if you were under that storm, maybe pouring down rain on you, you wouldn't be able to see anything anyway. But you could see, you'd be able to see the base of the clouds in this area a lot higher than you would in the southern parts of that storm. So the southwest quadrant of this storm is typically where you're going to get this tornado. So if you go up, now you got high reflectivities moved well to the east into that warning area, and then you got that overhang shooting all the way over. And then if your jet stream's coming over, you know, flowing west to east as it typically does, then you're getting that blow off. The cirrus blow off from the creating the anvil on the cumulonimbus clouds. So you got all that. Now see, as it keeps continue to push to the east, we're well up in the upper elevations of this storm, of this radar. So you still got those reflectivity. So that's being you got a lot of blow off right there. So if we go back all the way back down, let's do a volume scan right here in this blank area, and let's see what it has. See, you still have high reflectivities well in the upper levels. So that's where you're seeing all the blank at the bottom. Now it's opened up, because at the surface you're not seeing anything until you get up to about 10,000 feet or so. Then you can start seeing where those clouds are. But like I said, you wouldn't see that on the ground. You'd be pouring down so bad that you wouldn't see that. Now your rotation and then your tail, your storm, would be over here in these hook echoes where you got inflow, rotation. Let's look at the base velocity. See, you got look at where our radar is. We are on the radar to the north, so any radar pointing toward that radar, any reflectivity for the velocity. So the greens are going in, the reds are going out away from the radar. So our radar's to the northwest. So now you've got gate-to-gate shear. Right there in that storm, right there is where your tornado is going to be on the ground. There's your hail. Here's your lower speeds and the lower elevations. Now let's push this up. Let me zoom out just a little bit and we'll see what we got. Still have rotation inside that warning area. As you get up to the upper levels, then your rotation kind of weakens just quite a bit. So you don't see as much red and green. There's a cell of rotation right in that area all the way to the surface. So your tornado is probably going to be right in that area. We'd have to see. They didn't report where they seen the tornado on the ground. There was one confirmed. This is just a warning here, and radar indicated rotation. So on the other storm that was actually confirmed by spotters, it didn't show pinpoint the location of that. All right, so another tornado warning to the south. Let me get rid of that volume scan real quick. Let me pull this up and zoom in just a little bit. So if we can see any rotation here. We're getting on the outer edge of that radar, starting to get a little crowded. Really not on the edge of it, but a little further out, and it's just getting some. I don't really have a lot of tilt on that storm, as far as tilt on that radar in that area. But we definitely got the rotation there too, because our radar's to the north. Flow out, flow in, and then there's your gate-to-gate shear, just one pixel right next to the other. One's green going in, one's red coming out. There's your gate-to-gate shear for rotation. Alright, so get back to the base reflectivity. We pull this cross-section. I like to look at cross-section just to see what our tilt is on that storm. Break this up a little bit wider, and then you see that tilt, and you can see your updraft, and then you get your overshooting tops. Now, we'll pull a volume scan, and we'll fill that in solid. I'll show you what I mean for the how we can structure this whole thing. Alright, so like I said, you can see the outlines of the lower reflectivities well in the upper levels, pushing up well over 50,000 feet, and then your lower reflectivities or higher reflectivities getting to this core of this thing, and then we'll just go ahead and fill this in, and then get this out of your way. Okay, you don't see that, I don't think. Okay, you're good. Alright, it's just the tool I'm using to add and remove these. I don't want to be in the front of the screen that you're looking at. So, alright, we're going to go put everything into this picture right now. All reflectivities of that radar. So there's the structure of the radar. Now, here's some overshooting tops in the back, right over there to the right to the north. But this is a pretty heavy cell. That whole cell right there is just one big overshooting top. Basically you got 40,000 feet plus. The triple pulse ends about right around 30,000 feet. So here's a reflectivity, a little bit lighter reflectivity or heavier. I keep messing up. The outer ones are the weaker, lower reflectivities. You get higher as you go toward the center. So updraft, shooting well up to 40,000 feet, overshooting tops. This whole top of that storm is just pushing. That's a huge updraft, just pushing up above the tropopause. So into the tropopause, right above the troposphere. So high reflectivities in the core, well above 10,000 feet, and then once you're at 50 dBZs at 10,000 feet, you go severe. But this is a tornado warning, so this thing's definitely well past that. Now, we can break these down into separate reflectivities. This is the lowest reflectivity of the storm. And you can see the structure of the top of that thing. Now, as we go into the higher reflectivities, there's we go to the darker blue. You can see the structure of that storm coming to the center. And this is just one reflectivity level at a time. Get into the yellow, into the orange. And sometimes it's good to have that orange outlined on that red, because even though your reds, your high reflectivities are going to be severe no matter what, that orange is going to give you sometimes a little bit better picture of the structure of that storm. So you can see the rotation, updraft, tilt, and then starting a downdraft. So this is radar indicated rotation on this storm. We're setting that tornado. If there was something on the ground, somebody would have probably reported it by now. But let's keep going up to the higher reflectivities, and we break this storm all the way down to that. So we're ending right around pretty much 56 dBz. Once you hit about 60 is where you get into the purple color, and we don't have that. So we can bring that back up to a, you know, like I said, each one is separate. Now we go to the full volume. This is everything just filled in. You can see those layers all put together, solid. And then we can get rid of all the lower reflectivities. Come straight up to right around, let's go about 48 or so, or higher. Now we got some orange in there. Then we can pick up a little green. We'll stay on the higher ends of the green, and that's about right around 30 to between 30 and 40, closer to 40 dBz's on the higher reflectivities of the green. And then the blues, we're looking at about 27, 28. We'll pull some of that blue in there. And then the light blues are only about 10 to 20 on that reflectivity. So we could put a little bit in there too. And then that just gives us that clouded outline, just to show you how high that goes up into the upper levels, and then show the red and orange is your structure of the storm. So that's pretty much it on that one. Let's get back down here. There's the tornado right there. They're showing this was phone calls from storm chasers reporting tornado on the ground, chaser video of a tornado on the ground, and later reported damage including power lines down, time and location estimated via radar. So they didn't know exactly where they were. The storm survey will determine exact locations, and we just had another warning pop up to the south. Alright, so if we look at that one, right where that is, it's estimated by radar. They're going off that base velocity, looking at the rotation. So we shoot back a couple steps on this radar here, and we can see kind of what we got going on. So we have a little bit of a hooking right there. So it might be pretty close on that, just based on what radar they were looking at. Right there's pretty good. So if we did a cross section on that one, it's a little weak. I'm zoomed in way too far. All right, let's go. I think what this is doing is it's not doing the volume scan on this shot. It's doing a volume scan on the latest shot. So if we're pretty much at the last. That's why when we're trying to get right here, we're picking up those corners that are into the red. All right, so all right, pretty much it. Let's go with flash flooding over there in Louisiana. Severe thunderstorm over western Texas, and that's valid until 8 p.m. Central Time, 9 p.m. Eastern. And that is moving to the east at 20 miles per hour. Alright, let's go. That latest warning, let's see what we got on that. Pretty good tilt on that one, all the way up to 30,000 feet, and do a volume scan on this. And pull up the rotation. And we got rotation pretty much all through the upper levels on that storm too. So we're definitely, rotation indicated by radar justifies the that tornado warning. Okay, let's go back to the charts real quick. Let's see where we're at. Might just end the video here. Let's hit these charts real fast though, and then I'm not gonna go all the way to the upper levels. We're just gonna cover some more stuff. I want to see what's going on the surface a little bit better. All right. Sea level pressure and isotherms. Like I said, with those cold core systems, it's going to give you lower heights on the low pressure system, but it's going to give you, as that low pressure system moves to the east, it's going to give you a stronger core on the surface and push it through, and then give you a lot more lift right there. Maybe even a dry line. Let's see where we're at. So we can pinpoint that dry line. Let me get back over here. Alright, let's go. See what we got here. We should have brown on a dry line, but let's see. We got 40. Let's see, there's 77. It's pretty moist. 64. Once you get the dew points in the 60s, right there, I gotta clear this off because I want to see what those dew points are. Alright, let's just do the data plots for now. Oop, I'm trying to draw and I got my dragging my screen here. Okay, hold on. Alright, 66. 65. Like I said, once you're in the 60s, you can pretty much get severe weather in any of those areas. So that's pretty much all of Texas. 68. 77 to the south. All right, we're getting into the 50. 47. 83, 47. So if we had a dry line, it'd be well to the west part of Texas. Now, if you have a dry line, that cold core low, right at the edge of that with a cold dry air, but that's still pretty moist right there. We're showing cloudiness, rain, so that's not dry. Let's go 43 to 56, 33 to 65. I mean, 33 is a low dew point, but so I wouldn't really expect any severe weather out of that. But you're pushing almost 60 in the panhandle. Almost 60 here, 60 there, up to 61. I mean, pretty much anywhere through there you can end up with severe weather. So, low ceilings, severe weather, thunderstorms, pretty much happen all through here. All right, let's go get the national radar real quick. I didn't pull that up yet. We'll see what we're looking at for our storms. Then we'll hit the models real fast too. I want to check those out. Like I said, all through that area is where we're seeing the low ceilings. Here's where the severe weather was in Texas. I would look for some severe weather with this little with that squall line right there. But you see this rotation. You almost see that right there. So we had the high pressure system off the east, all that warm moist air from the south, and then warm air advection where our warm front was. They're coming down into this low, weak warm air advection, but it's almost like a bigger low or maybe an upper level low in that area. So, and then the cold front coming down, back to the west. So we're right through there. Expect maybe some water spouts off. There might be a marine warning down there. We have to look. I didn't see one. You got your tail right there. You got your severe weather in the panhandle. There was some right there, and then we did have that rotation right there. So we any of the drier airs right there in central Texas. So lower ceilings in precipitation throughout the central U.S. Like I said, with that warm air advection pushing to the north, and then that's going to push through Ohio. I've seen stratiform clouds in Ohio now, so expect that warm front to push through Ohio probably later tonight into the morning, and then I would expect the temperatures to rise. So we look at like, let's see, go back to our charts. Let's see what we got. Okay, warm air advection, like I said, from the south, 20 knots. Warm front, I'd say that warm front pushes through probably tonight into tomorrow morning. And then we got all these temperatures down here, upper 70s, 80. Is this a low pressure system? Let's go to the model, see what happens if we get that low pressure system right here develops and pushes to the northeast, and we got all that warm air advection, high pressure, that's ridged off over the southeast U.S. We got that high off the coast. Then that high pressure, that ridge weakening, allowing this low pressure to develop and push to the northeast, and we'll see what happens with that. We'll go to the charts for the go over to the models. Okay, so we got all the severe weather in Texas pushing to the east and then into Arkansas, and then that's pushing into Louisiana. And the big old, that's that low pressure system, it looks like, does develop out of New Mexico. It's just kind of popping up there, a big blob right there over eastern southeast Texas. Expect some severe weather right there. We got that's 18Z. Let's see, this is Valley. He's 18Z Wednesday, like maybe around noon or so. About noon and 1 on Wednesday Central Time. I think they're like 5 hours, so about 1 o'clock. And then pushing off the coast, a little bit of isolated stuff still hanging around on the East Coast. Once you get a low pressure system pushed through, or you get that path of least resistance now, then those air mass thunderstorms could pop up, just 18Z, 1 o'clock to 4 o'clock in the afternoon, and then cause that heating, and then just pop up that those thunderstorms again. These models sometimes don't pick that up, but if you have a system pushed through and there isn't high pressure that dominates and just suppresses all that, then you can actually get, just off the heating, redevelop those systems that went through. Just off of those systems, that instability, take advantage of it, the heating creating more instability, and then air mass thunderstorms just popping up like crazy. So we got the low pressure system over just north of the Four Corners over there. Another line, it looks like just high pressure dominates the East Coast. It kind of pushes back, looks like pushing to the west, and then just starts to wrap around. That's a little odd there. And then the low pressure system over Colorado, it just pushes up straight to the north, gets that wrap around, and severe thunderstorms pushing up into Wyoming, Montana looking like it's getting about the worst of it. So looks like our severe weather is going to be well to the west, and then that high pressure just pretty much ridging and just hanging out there, and then a low pressure, maybe a clipper shooting across the northern United States for maybe just catching the Great Lakes region, some North Dakota, northern Minnesota, pushing in, getting some rain showers there, and then some convection down here in back into Kansas, northern to Panhandle of Texas, back to what we're looking like today. And this is May 26th, 06Z on a Wednesday. It's overnight. And then that low pressure system over Wyoming pushing into South Dakota and dropping south, and then catches. Looks like maybe the jet stream steers that thing to the northeast. We have to get a good look at the jet too. But all right, then maybe, okay, the low pressure system does become well developed. Frontal system pushing all the way to the southwest over into Oklahoma, and now here's our whole big line of severe thunderstorms in Tornado Alley. All right, so Texas gets hit pretty hard. Oklahoma, Kansas, eastern Kansas, a little bit into Missouri, western Missouri, and then pretty much just dies out. And then high pressure dominates again. Your low pressure system is well developed with a warm occlusion or cold occlusion. That thing's it's occluded pretty good up there. Well developed system. If that actually develops out, I would like to take the charts and see what we can center on that low. And you see the baroclinicity in that, and we got I'd like to see how far in the upper levels that goes and what kind of stack it has, the jet support, and I mean, you're definitely got the support for it. Then that cold front. I mean, this thing just, here it is hanging out over the Great Lakes, well north of the Great Lakes region, the Hudson Bay area, and then pushing out to the east. I'd like to see one just hang out up there and just die. Usually what they do is they go well up closer to the Arctic Circle. That's where they spin out and die out. So high pressure dropping down. Let's see where that is coming from. So that's coming from the mountain area, the Rockies, and then pushing to the south and then back to the northeast. And then so I went, we're back into May, late May. So expect warmer temperatures with that. No severe, cold outbreak right there. If you've seen a cold core high push through with that heating and the moisture being pushed from the south, then you're getting some serious weather right there. But not there. I mean, we're just high pressure pushing through. Yeah, you get that low pressure system well developed, and Tornado Alley getting just exploding, and then that high pressure pushes to the east, and then straight to the north, and then over the Ohio Valley and the Appalachians. So looks like eastern Iowa getting a pretty good sell. Minnesota, let's back it up one, just popping up all of a sudden right there. June 1st, overnight, early in the morning, June 1st. Low pressure over Kansas. Looks like, does that develop? It kind of just hangs out there. And then another low pops up over Colorado. And that just kind of, that low pressure system's over Colorado and Kansas, just kind of sit there and push to the east over Kansas. And then I don't see it. It kind of dies out. And I'm going back and forth pretty quick, but dies out. And then low pressure well to over the Four Corners area again. Then high pressure to the north over North Dakota, and looks like maybe some severe weather for Ohio, southwest Ohio. And if that's the case, I will be running that one. That is 18Z Wednesday, so 1 o'clock. We're actually, I think we're a 5-hour difference, so roughly, that's about noon. We're only 4-hour difference, so for the Z time, that's right around noon. Wednesday, June 2nd. So if that pops, that's a 360-hour forecast. I don't know how that's going to hang out, but if that's right around noon, and then we get that severe weather, I'd like to see what the surface temps are going to be at that time. We get it to 18Z, 0Z, about 8 o'clock. I'd like to see about what the max temperature is going to be that day. And if we get the daytime heating with that, I think we could definitely see some severe weather here. So that'll probably be a day I take off work if that develops, and then go out there and chasing that one. Alright, so that pushes back, weakens out, pushes back to the south over the mountains, and then redevelops on the other side of the mountains. Low pressure sits over Ohio as a push from the east, or push from the west, and then out of Kansas, and then just over northern Illinois, and then back just over northern Ohio, northwest Ohio. So, all right, I'm going to go too quick on that for you. I mean, there's some pretty good stuff happening. I get pretty excited when Ohio actually gets hit. No one's seeing tornadoes or anything. Anybody get damaged, but I do want to go out there and start doing some chasing this summer. And we got a pretty good system building up right here. Let's get back to that. Tornado Alley, lighten up. So let me get this thing over here. I can draw on the screen. I want to see. Putting it on the display. It's not working out too good. Alright, we're just going to go ahead and end the video there. Thanks for watching, and subscribe to the channel. Share the the video, and help me build my channel. Thanks again for watching.